Jai Hind, everyone. Myself, Dr. Ajay Pratap Singh, and I am associate professor in Department of Mechanical Engineering at Ajay Kumar College, Ghaziabad, and I teach here the theory of machine uh, subject in this semester for the B.Tech third year students. In the previous lectures, I have discussed the various type of the linkage, degree of freedoms, then instantaneous centers, inversion of mechanism, basically 4 bar, then slider crank mechanism, double slider also, then the calculation of velocity, how to measure, so instantaneous centers we discussed, then relative velocity we discussed, and the previous lecture I have discussed the acceleration basically. Uh, all these have covered details, I think so. Only one thing is I forget the include, basically you can say the Corliss component, but then in future include the Corliss component, how to draw and how to find out and how it works. Now moving forwards, in this lecture basically I today discuss the lecture the CAM, right? And CAM is, you can say that the very important topic for designing of CAM is very important for the IC engines, opening of the valves, closing of the valves, the very important. So how it works? So in this lecture basically you can say I cover the basic of the CAMs, you can say that introduction, classification of CAM and follower, and how to the basic terminology. I will not discuss here the uniform velocity and uniform acceleration retardation and the simple harmonic motion, the motion of the basically the CAM profile motion. I will discuss in the next lecture basically, but previously I will in this lecture I will complete, we can say, the basic parameters, what is the basic uh, topic, like base circle is there, right? So what is the pitch circle, how to draw the CAM profile, all these things we'll discuss in the detail, so that if you find out the any problems in the CAM drawing, designing of the CAM with the knife edge follower, the roller follower or the flat face follower with the different motion with the uniform velocity or the uniform acceleration or the simple harmonic motion. So it's very easy to draw the follower and the CAM of the in the same axis on the different in the offset of this. So how much offset is there, so how to process to draw. So we'll discuss in this detail the designing of this CAM in the next lecture, but in this lecture we'll discuss the basic introduction of these CAMs and the classifications and the basic terminology I use in this CAM. So CAM, we can say a rotating machine element which gives the reciprocate or the oscillate the motion to another element is known as the follower. There are two things, one is the CAM and one is the follower, right? There are two elements, the different elements. So CAM is a rotating machine element which reciprocate or the oscillate with the motion to another element is known as follower, and the CAM and the follower is the line contact, or we can say the constitute of the higher pair, the point contact basically, and the CAMs are usually rotated at the uniform speed by a shaft, but the follower moves in predetermined and will be according to shape of the CAM. So different shape of the CAM is very important also. The CAM of the follower, we can say is one of the simplest as well as one of the most important mechanism to found in the modern machinery today, and we can say the CAM is widely used to operate the inlet and exhaust valve of the internal combustion engine, automobile attachment, machinery and paper cutting machine, shipping machine, and weaving and textile machine, and some you can say mechanism, fixed mechanism of the automatic lathe of the machines. So there are widely used of this the CAM, and different type of the shape of the CAM. The follower shape is also important. So according to that, we are using, and the large scale of this we can say that using in the automobile industry, combustion engines, opening the closing of the valves, the machine, cutting machine, paper cutting machines, also shipping machines. These are the widely used. We can say the classification of the follower, there are different parameters is there. First one is according to the surface in the contact. It means the cam and the follower contact in which shape. So according to contact, that is the one is the knife edge follower, second is the roller follower, flat face follower and spherical face follower. It means suppose these are the cam, right, and these are the follower. So it connect with that the surface in the contact and the surface contact of this follower and surface contact of the cam. So the follower is classified first of the according to surface of contact. So at that point that is a knife edge. Second one is roller follower. So output of this is the roller type. Then third one is the flat face. The surface is the flat connected with the attachment at the end of this, the flat or the mushroom type, and another is spherical shape. So there are different four shapes is there in the according to surface contact. Another you can say that the motion of the follower. So motion of the follower, that the reciprocating or the translating follower, and other is the oscillating or the rotating follower. So these are the follower types. Basically, we can say with the motion of the you can reciprocate or the translate or the oscillate about the rotating of the follower. Third classification is that we can say according to path of the motion of the follower. What is the path of the motion of the follower? So one is the radial follower and another is the offset follower. So I'll discuss all these things through the diagram in the next slide. So what is the radial follower? Radial follower, actually we can say when the motion of the follower is along and the axis of the center of the cam, right? Along the axis of the center of the cam is known as radial follower. But in case of offset follower, when the motion of the follower is along the axis of motion of follower is along an axis of away from the axis of the cam center, it is called the offset of the follower. So these are the axis of the cam and these are the axis of the follower. So these are shifted from here to here. So we can say that is the offset of the follower is there, right? And in the radial follower, there is the motion of the cam, that is center of the cam, and the center of cam and the follower along this action is the moving. So that we can say that the in the same line. So you can say that the radial follower and the offset in the both are the different cam center. So you can see in this figure, different types of the figure is here. That one is the cam with the knife edge follower, cam with the roller follower, cam with the flat face follower, cam with the spherical shape, cam with the spherical shape with the flat face follower, and one is the offset follower. So you can see in this figure number A, these are the followers, these are the shape of this type, and you can see that this is the center of this cam, the axis of the cam. These are the cam, basically you can say, and that the axis of this in the same axis, right? So the shape of this cam in this case, that is the point contact you can say, and the shape of this knife edge. So that's why I say that is the knife edge follower, right? Here you can see in the figure B, the follower of this one is, that is the roller follower, right? The shape of this follower in this case is roller follower. So we can see here that this type of the shape is known as the roller follower. Here the cam shape is the same in the all 6 figures, and you can see here the follower distance is like the flat face shape. So you can say that the flat face follower. Here that the cam shape with the spherical shape. So you can see that the shape is the spherical shape, and another cam is the spherical face follower. Here the cam is spherical face follower. Again the orientation of this will be same. In that case, that is the reciprocate, and in that case that is the oscillate, right? The orientation will be same, but position will be the connection between cam and follower, the shape of the follower will same. So you can different type of motion will be converted through this, and in this case that again that is the offset follower. So you can see here offset follower means from A to B, A, B, C, D, E, all these figures, A to E is known as radial follower, and figure F is known as offset follower. Right? You can see here the A to E from figure A, B, C, D and E is the radial follower, and figure F is known as the offset follower. What is the difference? The difference is the line of action of the cam and the follower, right? The center line of the center line, that the center line of this and the line of action of this follower is the same, but here you can in case of the radial follower, you can see here that the axis of the cam center is here and axis of cam center is here, but axis of follower is here, right? So in between that, this distance is known as offset of the cam, right? So if you if anyone asks, so you can draw this figure and it's very easily to understand to which type of the what is the difference between radial cam and offset cam. So just will draw this figure and understanding everyone, and just write the line of action of the center line and the line of action of the follower is the passes the same point, center point. So classification of cam, basically you can say there are two type of the cam is there. One is the radial or disc cam, and another is the cylindrical cam. So radial cam or disc cam is, that is, in the radial cam the follower reciprocate or the oscillate in the direction perpendicular to the cam axis. You can see in this figure number A, the cam as shown in the figure A as a radial cam, and cylindrical cam basically the follower reciprocate or oscillate in the direction parallel to the cam axis, and the follower rides as a for a groove at the cylindrical surface, and cylindrical grooves in the reciprocating and the oscillating follower. So you can see in this figure B, the figure B is shown that these oscillate like this, right? This is the reciprocate or the oscillate. So in that case, so we can say that the direction of parallel to the cam axis. So these are the cam axis, these are the cam axis, right? And these parallel to this axis basically you can say. And in case of, again in this case also, that the cam is the reciprocate or the oscillate, the direction is perpendicular to this axis basically you can say, perpendicular to the cam axis, and the groups is given in this. So you can see that the movement is according to like this. The cylindrical cam. Now come to this terminology, you can say some other classification, you can say the cam shape, that the shape base, then the follower movement and the manner of the oscillating. So the wedge cam is there, wedge cam and flat face, you can say. So cam has the wedge W, which is general, has the translational motion you can say. And you can see in the figure W, you can see that W has the cam you can represent, these are follower, and these are the W is represent the cam as the W. The wedges, the follower F can be either translate or the oscillate along this axis and used to maintain the contact between the cam. And the follower in the figure C, you can see in the figure, cam is stationary and its follower constant or the guide to G. So the relative motion with the cam and the follower. So we can see that in this case basically A and B, the follower F can be either translate or the oscillate, right? And the figure A, we can see in the figure C, you can say the cam is stationary. So in that case, the follower constant or guide through these G causes the relative motion of the cam in the follower. So use of in the some terminology, use the, you can say, the radial basic radial in the camps with the some basic point. So first of all, the base circle. So base circle we can know as the smallest circle can draw the camp profile. So we can see here the base circle. So we can see this the blue color, the first one I'll draw in this green color. This is the cam shaft, right? This is the cam shaft. On the basis of cam shaft, we draw the base circle. So base circle I'll draw in here the black color. So base circle you can see here is the smallest circle, and through this circle we can draw the cam profile, right? In the black color I'll draw here. Then trace point, if the reference point of the follower are used to generate the pitch curve. So in case of knife edge follower, the knife edge represent the trace point. So you can see here the trace point. The trace point, this point is the trace point. You can see that in this case, I have draw here the roller follower basically. So roller follower is there. So center of this roller follower is known as the trace point. But in case of the follower, suppose these are base circle, right? And this is the camshaft. These are the axis. So in case of, please see here, in case of roller follower, right? So in case of roller follower, trace point is the center point of this roller. But in case of, I'll draw here in some other color so you can understand. So in case of knife edge follower, the trace point is the touch point of the base circle, right? So in case of knife edge follower, the knife edge represent the trace point at the pitch curve correspond to cam profile, and a roller follower that represent the trace point, the center of the roller. So difference between you can understand. Third one is pressure angle. So pressure angle you can say the angle between the direction of follower motion and the normal to the pitch curve. And this angle is very important to designing of the cam profile. If the pressure angle is too larger, the reciprocating follower will be jammed in the bearing, right? So pressure angle is maintained. Now pitch point on the pitch curve has the maximum pressure angle, where the maximum pressure angle will happen. This is known as pitch point. Then what is the pitch circle? So pitch circle is drawn the center of the cam through the pitch point. So we can find out the maximum pressure angle. So we can find out the maximum pressure angle somewhere in that point. The follower motion is here. So we can draw the pitch circle maximum where the maximum pressure angle is given. So you can draw this pitch circle, right? So what is the pitch curve? Pitch curve is the curve generated by the trace point as the follower moves the relative to the cam, and from the knife edge follower. So first of all draw this trace point. So trace point it does in case of center of roller, the trace point is there. So I'll draw here in this light green. So you can see, or a blue color, purple color, right? So trace point, trace pitch curve is generated through trace point of follower the cam and pitch point. So these are basically, you can see here this circle it draw in the purple color, right? So in the pitch curve, the curve generated by the trace point is the follower moves related to the cam. But in case of, you can say, the knife edge follower, the pitch curve and the cam profile are the same, whereas the roller follower, they are separated by the radius of the roller, right? So lift of the stroke is there. So lift of the stroke is there. If the maximum travel of the follower from the lowest position to the topmost position, so these are the follower moves like this. So we can say that the total length will be covered. So we can say that the reciprocating follower and travel of this. So you can lift of the stroke. Then come to prime circle, and the prime circle is the smallest circle that can be drawn from the center of the cam and tangent to the pitch curve. For the knife edge and the flat face follower, the prime circle and the base circle are identical. So I here in draw this with the purple color. These are basically the prime circle, and in case of basically we can say the flat face follower, or we can the knife edge follower. So these in that case the base circle. In that case, this base circle is known as the prime circle, or we can say the base circle and prime circle identical in case of the knife edge follower or in the flat face follower, right? And in case of the radial, in case of we can say the roller forward has a radius difference. So this purple color represent that is this one represented by the black color. So you can say that is the prime circle, right? So here is the maximum. These are basic phenomena. You can draw this pitch curve, pitch point, cam start, pitch circle, then base circle, cam profile, then prime circle. So you can draw, and according to that you can find out. So the cam circle will draw. So suppose the cam profile will draw. So what will be happen in the rotation of the 360 degree of the cam? Suppose this shape of the cam. These are the shape of the cam, and the shape of the cam like this, like not a full circle. So shape of the cam is this. So what will be happen? There are some theta 0, that is outer stroke, return stroke, dwell period. So that is theta equal to 360 degree cam will be rotate. So what will be happen? There are some 0 to some distance 90 degree, or for example for the rise value will the rise, the cam will be go to the follower will go to rise after a certain times, that will the rest position, then follower return position, and then come to this again rest position. So rise, dwell, rest position, then return, and then dwell. So these are the combination of this, and the 360 will move. According to that, we will draw this the cam profile on this, right? So I hope you have understand the basic idea about the for in terms of the cam, and you find out the basic introductions, the camps classification and follower classifications. In the next lecture, we will discuss the different types of motions, how to acceleration diagram will how to cam profile will draw for in the different types of motion, like uniform velocity, uniform acceleration retardation, or with the follower motion, the simple harmonic motion, or the cycloidal motion. So in that case, will the 4 basically cases, and the next lecture will consider all these 4 cases, and after that we will take the some numericals and find out how to draw this base the cam profile of this with the cylindrical cam as well as the offset cam and radial cam, right? So thank you so much, guys. Thank you so much. If you have any query, please feel free to contact with us in my mail ID, the Pratap Ajay @akjc.ac.in. Thank you so much.